An overview to the DMAIC project guideline with a summary of the tools in its phases might serve as a guideline for your Six Sigma project. There are 2 columns in this guideline with a sequence of the DMAIC phases: define and measure on the left, and analyze, improve and control on the right. All blocks in the columns correspond to just one tool. On the right side of each tool you find traffic lights showing you who should participate in this tool. The legend on the bottom of the guideline assigns the different colors: red for the management, yellow for the green or black belt, and green for the team. The bullets in the explanations of each tool show you whether the Sigma guide or a statistical program, for example Minitab, supports the execution of the corresponding DMAIC tool. The define phase starts with the identification of a project topic. Not all challenges in a company are suitable for Six Sigma. At first you should identify a weakness in your processes, i.e. a weakness of your products and services. If a process is repeated, if there are more than about 10 products or services generated or delivered per month, if the products or services show a weakness in quality, availability or resource consumption, if an internal or external customer is affected by this problem, and if the causes of the problems are suspected within the company's processes, then the topic is probably suitable for a Six Sigma project. After the project topic has been identified, it should be further defined. In the first step, the process and its output is specified. Then the problems are defined as deviations of the output in terms of quality, availability and resource consumption. Next, the effects of the problems on the company and the customer are rated according to given data. The quality costs of the problems for the company and further financial losses should be estimated here. This is the base to calculate the potential benefits of the project. Then the existing ideas for the solution of the problems can be collected to later acknowledge already existing good ideas and to reduce resistance to the solutions in the improve phase. This information is summarized in the project definition. And the project definition might support the management in their decision which of the defined projects could be implemented by a green or black belt with the support of a sponsor from the management. Now the project can start with the SIPOC. This tool draws the borders of the process field with the first relevant input, which might already cause the problem, and the last relevant output, which has the problem. The process line between the first input and the last output is structured into the main process steps. Each of these process steps leads to an intermediate output. All these intermediate outputs might also be associated with preliminary problems. Thus, it is necessary to identify the customer of all these outputs who are affected by their problems. The next tool of the define phase, voice to criticals, continues with the outputs of the SIPOC and the customer. Here it is necessary to ask the customer for their positive and negative feedback to these outputs. These voices of customer are translated into critical requirements and then into problems, which are the deviations from the requirements. A classification of these requirements according to the Kano model and the rating how well they are fulfilled leads to the severe problems, the critical to quality. The important information is now summarized in the project charter. Like the business case from the project definition, the problems of the outputs, and the effects on the customer and on the company. Objectives of the project are formulated according to the defined problems. Further specifications about the scope of the project, what is in and what is out, specifies the duties for the green and black belt and assures the expected results for the management and the sponsor. After the necessary experts of the project team are determined, as well as the deadlines for the further DMAIC phases, the measure phase can be started. While the primary purpose of the define phase is to identify the whys, i.e. the problems of the outputs, the purpose of the measure phase is to specify the negative influences on the output which trigger the problems. These axes in the input and the activities of the process, in the used methods and resources, together with hypotheses about the relationship, serve to solve the central equation of Six Sigma. Y is a function of x. First, the external inputs are analyzed, listed already in the SciPoc. The requirements of the process on these inputs are evaluated here, as well as their deficiencies, which might have a negative impact on the outputs and trigger its problems. Next, the major process steps of the SciPoc are mapped in more detailed activities. It is a good idea to perform this mapping together with the experts of the process and to just follow and observe, as far as possible, the generation of a certain product or service along its value chain. For each activity, the guiding methods and executing resources should be specified. This life scenario serves as the background to identify all negative influences in the process on the problems. Please be very specific here, because the results of the input and process mapping analysis are the rational base for the statistical tests later in the analysis phase. But before we can analyze data, we need to collect data. And before we collect data, we should formulate hypotheses for the problems and their related influences. The cause and effect matrix prepares these hypotheses. In the rows of the matrix, all detected influences from the input and the process are contrasted to the columns with all identified problems. Experts now rate the degree of relationship between all influences and all problems. The result is a ranking of all influence-problem relationships, according to their strength. At least it is your decision which of the evaluated XY relationships should be statistically investigated. In some cases, it might be easy to collect data from given databases, or in other cases, it might be difficult or even impossible to measure data. It might even be unnecessary to collect data at all. For example, if you detected in your process mapping analysis that there is no standard procedure defined to guide the activities like recipes do. Simply by reasoning, we know that varying personal preferences in performing the activities will lead to variations of the outputs and thus to problems. Now the prioritized influences and problems from the cause and effect matrix are operationalized in the data collection plan. This means that the corresponding measurements and their units of measurement are specified, as well as their scale level as cardinal, ordinal, or nominal. Based on this operationalization, the statistical hypothesis for x and y can be formulated, either as relationship hypothesis, there is a or no relationship between x and y, or a difference hypothesis, there is a or no difference in y's between levels of x. The hypothesis and the scale level of x and y determine the appropriate graphical representations and the appropriate statistical tests. If there are doubts whether the data will be reliable, especially if the data are gathered by different people with different expertise or ambivalent measurement standards, it is recommended to perform a measurement system analysis to standardize the measurement. Now the data can be collected according to a sampling plan with a certain sample size depending on the selected statistical test and a schedule depending on the flow and properties of the data. After the data collection, the measurement phase is completed. The analysis phase starts with a plausibility check of the collected data. Depending on the scale level of the variables, the evaluation of the min and max values and the statistical parameters is recommended. A graphical analysis of the data with a check of their distribution as well as their progress over time complete these first inspections. Now the performance of the process can be determined by calculating the process capability and by generating control charts to determine patterns and signals in the data over time. In the next step, the hypotheses are statistically tested. Every statistical test gives you two important results. The p-value about the statistical significance lets you decide either to confirm or to reject the H0 hypothesis in favor of the HA hypothesis. If you accept the HA hypothesis, the p-value tells you how reliable your statement about the tested difference or relationship is. But is your result not only statistically significant, but also practically relevant? This practical relevance concerns the degree of the difference or the degree of the relationship. However, if you find a significant and relevant relationship between an influence, for example the amount of chocolate, and an important attribute of the output, for example the taste of the cookie, this might be the starting point for the search of underlying root causes. In some cases, you might not have any data available for this deeper going analysis to explain causes of the problem. A rational root cause analysis can here support finding the root causes of the influences of the problem. This is done in a cascade of why questions with the experts in your team, leading to a hierarchy tree of causes with the problem at the top and the root causes at the bottom. The root causes are the anchor point for solutions in the beginning of the improve phase. A workshop with the experts might be sufficient to develop solution ideas to eliminate or circumvent the root causes and thus to solve the problems. In those areas where technical parameters need to be adjusted, a design of experiments might be helpful to systematically identify the best adjustments of a bundle of root causes to optimize one or more parameters of the output. All solutions with a positive benefit-effort ratio, which are also supported by the sponsor, are specified in an action list. Here you should be very specific about who does what till when. The level of concreteness of the action items often determines the success of their implementation. There might, however, be failures or harmful secondary effects associated with the action items. The failure mode and effect analysis serves to reduce these risks. After you have formulated appropriate countermeasures against the risks of your actions, you can implement both actions and countermeasures. It is necessary that your sponsor supports this implementation by informing and motivating the employees, especially those who were not involved in the project. At least it is important that the sponsor publicly presents the planned actions and commits to control their implementation and their success. After the implementation, new data for the new process are collected for the control phase. The process capability is again calculated and control charts are generated to determine patterns and signals in the data over time. With the statistical test, you should calculate the difference between the performance of the process before and after its improvement. Please find out whether this difference is statistically significant and practically relevant. The degree of this before-after difference can help to calculate the financial benefits of the project. This is an important advantage of Six Sigma, that you can reliably assess the actual results of the process and their effects on the company and on the customer. To assure the sustainability of your improvements over time, at least a process management plan should be developed. It supports to continuously monitor the process with control charts and gives recommendations what to do if the process gets out of control. This completes your storyboard of your project, where you should continually record what you and your team did along the DMAC phases. I hope that the responsible managers and your sponsor acknowledge your performance and the performance of the whole team. Maybe your storyboard becomes one deliverable of your green belt or black belt certification. The project itself is finished here, but it is an ongoing task of the responsible manager to lead the process to a continuous improvement, with involving all employees, for no process is ever perfect. Six Sigma is a vision, and a Six Sigma project is just one step to this perfection.